Hi students, this is AJ sir. Let's study 10th standard ICSE math, exercise 21B, trigonometrical identities, part 2. Exercise 21B, cancel question 1.1, 1.2 mark it as IMP. Let's start with the LHS. We see cube formulae can be applied here. A cube plus B cube is A plus B, A square minus AB plus B squared. And A cube minus B cube formula is A minus B, A square plus AB plus B squared. And then the denominators are as it is. Here, the denominator gets cancelled, bracket cancelled, bracket cancelled. So now there is no denominator. Bring the numerators together, open the brackets. Again, minus sin A cos A plus sin A cos A cancelled. Sin squared plus cos squared A is 1. Also sin square A plus cos square A is 1. So 1 plus 1 is equal to 2. That's the RHS. Now Roman number 4. Again here we'll start with the LHS. First we should convert the tan into sin and cos. And then we see that the denominators are same, so no need for LCM. Get the numerators together. So this becomes bracket squared plus bracket squared. Note that the square is for the numerator and denominator both. So actually the denominator is cos square A, and even here it's cos squared A. So no need for LCM again. Get the numerators together. If you look at the RHS, they want everything in terms of sine. So we'll open the brackets in the numerator, but even in the denominator, we'll convert cos square A into sine square A, because the formula is cos square A is equal to 1 minus sine squared A. If you've forgotten the formulae, please revise that first before solving ahead. Revise all the formulae from the textbook. Now when you open the brackets, which is A plus B the whole square and A minus B the whole square formula, we can cancel 2 sin A and minus 2 sin A. That leaves us with 2 sine squared A plus 2. So if you remove 2 common, you have sine squared A plus 1 upon 1 minus sine squared A, which is the RHS. Next, the sixth sum. So again, we'll start with the LHS. The denominators are not the same, so we have no choice but to do LCM out here. So after LCM, we got bracket into bracket plus bracket into bracket upon the common denominator, which is again bracket into bracket. Now this is A plus B, A minus B. So use the formula A squared minus B squared. Same thing here, A squared minus B squared. The denominator, let it be as it is. Don't open it. The RHS is 0. So I reckon the numerator is bound to become 0, and 0 upon anything is 0. If you notice, sine square A plus cos square A is 1. So rearranging the terms, and if I remove minus common out here in brackets, I get sine square B plus cos square B. Even that is equal to 1. So 1 minus 1 gives me a 0, and so the answer is 0, which is equal to the RHS. Next, the 8th question. On the LHS we just have tan, and on the RHS we just have sec squared. So definitely they will use a formula where we can convert tan square into sec square. You know, tan square is equal to sec square minus 1. But before that, let's open the brackets. A plus B the whole square is A square plus B square plus 2AB. And A minus B the whole square is also A square plus B square minus 2AB. So I see that 2 tan A tan B and minus 2 tan A tan B get cancelled. What else? So I've got 4 terms left. But here we have 2 methods. What I have done is I've converted tan square A as sec square A minus 1, tan square b as sec square b minus 1. Same thing here, convert and convert. By the way, there's a dot here, multiplication. So even here there's a multiplication. Now open this brackets, distributive multiplication. Be careful about the sign. You see minus into minus becomes plus out here. So finally, the 1 minus 1 gets cancelled, minus 1 gets cancelled, sec square a minus sec square a, sec square b and minus sec square b. So the only thing left is sec square a into sec square b, which is the RHS. Now the other method is that after this step, the third step where you have 4 terms, I'm going to group them. So 1 plus tan square a together, and the remaining 2 terms I can see tan square b is common. So I'm taking plus tan square b common. So what is left in the bracket is 1 plus tan square a, which matches this bracket as well. So if I take this bracket out common, what is left in the brackets? From here 1 is left, plus tan square b is left. And 1 plus tan square a is sec square a, 1 plus tan square b is sec square b. So we got the RHS. So this is the shorter method, but whatever strikes you, whatever you find it easy, use that method. Next, question 3. If m is equal to a sec a plus b tan a and n is equal to blah blah, prove that m square minus n square is equal to a square minus b square. Now this sum is no different than the usual proving sums. There is nothing special about these types of sums. We have to use the same tricks. So we start with the LHS, which is m square minus n squared. We substitute the values of m and n, which is given in the question. So this basically has become the bracket squared minus the bracket squared. We have no choice but to open the brackets now. So this will become a squared sec square a plus b squared tan squared a plus 2ab sec a tan a. That is a plus b the whole squared is a squared plus b squared plus 2ab minus sign. And the same thing goes for the other bracket. A plus b the whole squared, again a squared plus b squared plus 2ab. When I say ab, I mean the first term and the second term, not just the variables a and b. The brackets were necessary because when we will open this bracket, the minus sign is going to change the signs of all of these, due to which this and this will get cancelled, that is this and this. And then I'm rearranging the terms. I would like to have the a squared terms together and the b squared terms together, so that I can remove a squared common out here and minus b squared common out here. And I notice that what is left in the brackets is actually a formula. Sec square a minus tan square a is 1. So the brackets disappear. I'm left with a square minus b square, which is the RHS. Next, the fifth sum. Again, they have given the values of m and n and we have to prove something. So we start with the LHS, which is more complicated than the RHS. We just substitute the value of n and m, and now the sum is a usual proving sum. So first thing, convert second cosecant terms of cos and sine. An LCM will be required out here. Here, use a plus b the whole squared formula, a square plus b square plus 2ab. By the way, did you notice sine square a plus cos square a is 1? Come on, by now you should be able to visualize these formulae in every step. It should strike you immediately, which is possible only if you've learned the formulae very well. So next step, after taking LCM, I get this. The 1 and the minus 1 disappear, leaving me with this. And sine a cos a cancelled. So the only thing left here is this. And of course, this is nothing but m. Keep checking the question. So it's 2m, which is the RHS. Now the seventh sum. Mark it as IMP. Values of m and n are given. We shall simply substitute the values of m and n. So m squared will become this, n squared will become that. And when I say square, it is for denominator as well, which is not the same, so LCM is required. So here into sine square b into sine square b, here into cos square b into cos square b. So that way the denominator becomes the same, so we can bring the numerators together. But in the numerator, I can remove cos square a common. So do that. So what is left is sine square b plus cos square b. And in the denominator, this cos square b got cancelled by this because there's a multiplication here. Now this bracket is equal to 1. So the only thing left is cos square a upon sine square b, which is n squared, and that's the RHS. So that's how we prove it. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.